Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Good morning. I'm Kevin Schofield, General Manager here at Microsoft Research. I want to thank you all for coming today as we celebrate 15th anniversary of Microsoft Research. It's been quite an adventure for us over 15 years, and we hope to share some of that, a little bit of a retrospective with you this morning on this. Bill Gates really wanted to be here in person this morning, was not able to make it because he had to be out of town, but we actually have a few words from Bill on video, so let's share those with you right now.
When Microsoft Research opened its doors on August 28, 1991, Microsoft became one of the first software companies to create its own computer science research organization. In the 15 years since then, we've been turning ideas into reality. Today, Microsoft Research is an incredibly diverse organization with more than 700 scientists working in 55 research areas in 5 research labs around the globe. From computer scientists to mathematicians, anthropologists, and sociologists, Microsoft researchers are committed to developing innovative technology that will benefit people around the world. During the last 15 years, Microsoft Research has tackled some of the biggest challenges in computing and made significant contributions to Microsoft products. There are countless examples: Superfetch in Windows Vista, TrueSkill Player ranking for Xbox, the smart screen technology that's at the core of our anti-spam filters found in Outlook, Exchange Server, and Windows Live Mail. Not only do researchers at Microsoft Research contribute to the company by developing new technologies and transferring them into Microsoft products, but they also help to provide economic opportunities for other companies. Through our IP Ventures program, they are helping startup companies bring new products to market based on our licensed technology. As an open research lab, Microsoft Research is committed to collaboration and advancement of the computer industry worldwide. Evidence of that commitment is the fact that our researchers have had more than 3,700 published papers accepted to industry and research conferences in 15 years. That's an average of nearly 1 paper for every working day since Microsoft Research was founded. Looking ahead, we've really only scratched the surface of what computers can do. Today, the computer as we know it is changing, and I have no doubt that Microsoft Research will play a fundamental role in shaping what comes next. From services to speech recognition, machine learning, human-computer interaction, and dozens of other areas, Microsoft Research will continue to focus on defining the future of technology. I'm incredibly proud of what Microsoft Research has accomplished during their first 15 years. And I'm looking forward to what the next 15 years and beyond will bring.
So one of the things that we've learned in Microsoft Research over 15 years is that it's very hard to sort of capture the gestalt, sort of, what's behind a research lab in a PowerPoint slide deck. So we're committed to being PowerPoint free today. But we actually have a great full morning planned here. A little later this morning, Dan Ling, who's the Corporate Vice President and head of our Redmond Research Lab here, is going to actually share with us, and he's going to bring in some of our researchers and share with us some of the technology investments that we've been making for almost as long as Microsoft Research has been going on. And so you can see actually some of the great payoff that these 4 different areas have brought with us. We're going to have an opportunity for open Q&A later on this morning. But we want to start out this morning with a conversation. Really sort of take some time and be a little more thoughtful about why Microsoft has a research lab, why that's important for a software organization like Microsoft, how we think about ROI for a research lab in a corporate environment like this. And we're very privileged this morning to have with us President Mark Emmert from the University of Washington, and Dr. Rick Rashid, who is the Senior Vice President and Head of Microsoft Research Worldwide, here with us this morning. So at this point, I'd like to bring them up and turn the floor over to them.
Thanks, Kevin.
Mark.
Good to see you.
Thank you. Oh, so I'm sitting on this side.
Yes.
We were having the discussion about which side we should sit on. So,
and what would be a political statement and what wouldn't. So. I'm on your left, you might note. The format for what we're going to do today is we're going to just chat with each other about this whole enterprise that's been running now for 15 years. And we've got a chance to hear some of Rick's thoughts on what's really been going on, what the future it holds, and why this kind of an enterprise makes sense in an organization like Microsoft, because it's really quite distinctive and very unusual. And let me start there, Rick. 15 years ago, you were brought in from the academy, where you'd had a very distinguished career as a computer science professor and researcher, to found this brand new enterprise. And at that moment, what were you trying to accomplish 15 years ago? And looking back on those 15 years, how do you think that experiment's gone?
It's interesting. I was when I was considering taking the job, to come to Microsoft, I had the rare opportunity of really being able to get some tremendous advice from one of the great leaders in the field, Alan Newell. Alan's was a Turing Award winner. He was the founder of the computer science department at Carnegie Mellon, where I was, and he'd been involved in getting RAND going. So he had a lot of experience in really, how do you start and how do you maintain a great research environment. And I had a chance to talk with him. Unfortunately, at the time, he was ill, and he knew he was likely to be passing away from cancer. So it was kind of very important at the time to talk with him as well. But he gave me a great collection of advice about what it takes to really make a great research lab, and in some sense also the feeling for how difficult it was going to be. He wanted to make sure I understood that, and how fragile such an enterprise can be in terms of creating the right kind of environment and making sure you have it. I think the key things that I got from my conversations with Alan were, first and foremost, that you had to bring in great people. It was extremely important that when you're hiring really for talent and not so much for what it is those people actually do. A lot of times people today will ask me, well, do you have specific research areas you're trying to hire in, or what is your focus? And I think the answer is always, when we have an opportunity to hire great researchers, whether it's great young people coming out of PhD programs or established researchers that have really created great careers and have continued to be innovative through those careers, we'll take that opportunity. It doesn't matter what area they're actually working in.
Sure.
Historically, that's always proven to be the best way to create a great research environment. The other aspect is that you really have to have an environment which is focused on moving the state of the art forward. It's in some sense more important to me that Microsoft Research is at the forefront of our research areas than it is that we're doing anything that's specifically related to Microsoft. I mean, if we're doing great research, then we'll find a way of making that relevant to Microsoft. I mean, great research has that quality. If we're not doing great research, there's really no reason for us to exist. So early on, I wanted to create an environment that had great people, that was open, where we were taking our research and subjecting it to peer review in the same way you would be doing that in a university environment, so that your strongest critics, in some sense, had the opportunity to say whether you were really doing innovative work or not. And then I did also want to create a research environment that really worked well in the context of a software company like Microsoft. And my feeling at the time was that, and really the reason I took the job, because I could have done research in the university, was my feeling that the input to a company like Microsoft was the natural output of a research lab. It was the ideas, the innovations, the artifacts that get created in research, the algorithms that can be used to do computer science. That was a perfect input to the product creation process at a company like Microsoft. So that's what I was hoping to do, and I feel good about where we've come.
Good. If you had to go back over these 15 years and point to a few key discoveries or research outcomes that you're most excited about or proud of, what would those be?
Well, there are many points that I could pick that I think were sort of critical to the way the organization's been shaped. For example, really early on, actually going back to 1992, we were working on technologies for optimizing how 32-bit code ran. And the goal of that work was really very mathematical work. It was very theoretical, but the idea was to come up with new ways of arranging 32-bit code so that when you executed it would take up less space in memory. Now, we're really proud of that work. We're always pretty much proud of our own work. And we talked with the product teams at the time, and the reaction we got was kind of interesting. It was very much of the well, you guys are really incredibly smart, and we really appreciate you, but we don't actually have that problem. But we really appreciate that you worked on this, and boy, you guys are really smart. 3 years later, it turned out that the company really needed that research. We were trying to ship Windows and Office at the same time, and because of some trade issues at the time between the United States and Asia, DRAM prices were abnormally high, and so the size of memory in computers of that day hadn't really increased the way people were expecting it to. Of course, 32-bit code took up twice as much space as the old 16-bit code did, and so it was important that we find a way to get that space back. And so that technology was critical to allowing us to succeed in that product ship. That was an important period for the company. And I think the fact that we worked so closely with the product teams at that point established a long-term relationship with them that we've built on over time in terms of technology transfer. Another point that I think was particularly important, to me at least, was going back to 1996 when, in that particular year at SIGGRAPH, 20% of the papers at SIGGRAPH that year, which is the top graphics conference that's held every year, 20% of those papers had a Microsoft author. And wow. In some sense, that was almost like a coming out party for the organization. We'd grown at that point in time to about 100 researchers, and that got people in the academic community to really sit up and take notice that, wow, there's some incredible research going on there. These people have built a tremendous research organization. And I can just remember meeting with Nathan Myhrvold, who's my boss at the time, was running our advanced technology division, which research was a part at that time. And I went into his office, and it was just a few weeks after that conference, and just spontaneously we started smiling and laughing because we were both thinking the same things. Like, wow, we started this enterprise. 5 years later, it really seems like it's taken off. And it was at that point that we decided to start expanding outside the United States. The feeling was we'd been able to establish a strong research group here, and now it was something where we could start trying to attract some of the great talent that was outside the United States as well.
Both you and Bill in the video talked about the essential nature of Microsoft Research as being an open research enterprise. That, of course, is how the Academy works. That's how I'm accustomed to overseeing research activities. But it does cause us a lot of challenges when we have to go to taxpayers and other funders who say, okay, what's the return on investment here? What are we all going to get out of this? Now, I think Microsoft's extraordinarily unusual in the fact that you're one of the few really serious research as well as R&D enterprises going on out there. And then you've got this open characteristic as well. Why is it critical that you be open? And secondly, closely related to that, given that you're an open research enterprise, how does Steve Ballmer assess return on investment for what is a very large-scale investment in computer science research. In fact, I think it's as big as NSF's computer science budget or something close to it.
Probably not quite that big.
It's pretty close.
But, well, the reason it's important that we're open is it's critical for us to be doing the best work we possibly can. I want to attract the best researchers, and I want to ensure that they're doing top quality research. And frankly, the only way you can be sure that you're doing that is to be open and to subject yourself to external peer review. I mean, there are many issues that people have with the peer review process. I mean, it's not always perfect, but it's the best way that the academic community has been able to come up with to really assess, are you innovating? Are you doing new work? Are you doing work that's scientifically significant? And by keeping the environment open, by subjecting ourselves to external criticism and review, it really helps to ensure that we're really doing the best work. Mm-hmm. I mean, you can bring a lot of great people together, and there's plenty of examples of that historically, where you bring a bunch of great people together, you have a closed environment, and for some short period of time, those people can do excellent work because they're building on what they're building on what they've done before. But you can't sustain that without external review. You can't sustain that without the criticism of your peers. And so that's why, to me, it's important. And frankly, I don't think you can hire great people unless you're able to show new people that you're doing good work. And then by keeping yourself open, it allows you to do that. In terms of return on investment, I mean, both Steve Ballmer and Bill Gates have been quoted publicly, which is great for me, saying Microsoft Research is the best investment Microsoft makes. And what they're doing is they're looking at the historical results. I mean, there are virtually no products Microsoft produces today that have not either taken technology from research, come directly out of research, or been built using the tools and technologies we've created within research. Microsoft Research has allowed Microsoft to enter into new businesses, to meet new competitors, or to respond to changing business conditions. So we're really able to allow Microsoft to be more agile as it confronts new challenges. And for a company like Microsoft, that's absolutely critical. I mean, in the technology field, if you're not able to change, if you're not able to adapt, if you're not able to innovate, you're not going to be around. And one of the things I like to say is the reason we have Microsoft Research is so Microsoft will still be here 10 or 15 years from now.
Yeah, surely. You do a good deal of work in collaboration with universities in the United States and around the world. University of Washington has some terrific collaborations with you in a number of fields, and of course you're doing it in Europe and around the country and now in Asia as well. Tell us about why you do that in collaboration with universities and what you hope to gain out of that process. I understand why it's clearly advantageous for us in the academy. What's in it for Microsoft?
Well, it's interesting. One of the very first things we did when we started Microsoft Research, really before we'd hired very many researchers, was to create a technical advisory board composed of academics that would advise us in what we were doing, criticize us if we were doing things wrong, and give us better insight into what was happening in the academic world. For me, that connection back to the university environment is super important. For one reason, because we're not going to do all the research in the world. I mean, I don't care how big Microsoft Research becomes. The academic community, the center of gravity is in universities. It's not in corporations. Mm-hmm. And so it's important for us to know what's happening in research in the university environment, to work with universities, to be able to connect with innovative work like at the University of Washington, where we've done several collaborations, so that we can be aware of what's happening and be part of that innovation as it occurs, and where it makes sense to help bring those innovations from universities into the company. Because Microsoft needs to continue to innovate. And Microsoft Research is not going to create all those innovations. We're going to bring many of them in from the outside, whether it's working with academia or buying technology from other companies.
Mm-hmm.
So that's important. Obviously, the lifeblood of a research group is its researchers. And so for us, it's also important to work with the academic community, because we want to be the place where the best and brightest young PhD students want to go work. You know, we've been, I think, particularly successful in continuing to hire some of the really best graduate students coming out of PhD programs, and that's really had that's allowed us to grow. That's really made the difference for us. We actually run what I believe is the largest PhD internship program in computer science in the world. And again, it's part of both the way we interact with universities, but it's also part of the way we help to recruit, because we get to show all these young students what it's like working at Microsoft Research, what kind of environment we have, why that's a good place for them when they eventually graduate. That program, just in the United States this year, just in Redmond, in fact, we had over 250 PhD interns. To put that in perspective, the United States only produces about 1,200 PhDs a year in computer science. So a significant fraction of the cohort of PhD students will have worked at Microsoft Research. And worldwide, we have more than 700 interns in our research labs. So it's a huge program. And again, it's another way that we work with universities. So really for us, it's about connecting with the research, about working with students, hiring great students, and frankly making sure, one of our goals has always been to make sure that the university system is healthy, that we do what we can, to ensure that computer science departments and some of the top engineering schools in this country you really are able to do their best work. And a lot of times we'll actually fund work in new areas that may not yet have gotten the attention of governmental funding agencies, because we can do that. We can be nimble in the way we work with universities.
Mm-hmm. Talk a little bit about, if you would please, the international strategy you have with your laboratories. You talked about the huge proportion of PhDs who are interning with you now, and you've now established research centers in a number of different locations. What's that strategy about, and where do you see that going over the next 15 years, let's say?
Well, it's interesting that if you go back to the earliest document that described what Microsoft Research might be like, it was actually a memo written by Nathan Myhrvold to the Microsoft board back in 1990. And in that memo, he talked about starting a research lab in the United States, and then one in Europe, and then one in Asia. And it's funny because he never showed me the memo. We never actually talked about it. When I felt we'd gotten established in the United States, and I first started talking with Nathan and talking with Bill about the possibility of starting research labs outside the U.S. And the goal I had was to really capture the talent that those areas of the world have. Not everybody wants to work in the United States. We have tremendously great researchers coming out of universities in Europe, coming out of universities in Asia, and my feeling was that as long as we were simply U.S.-centric, our growth would be limited. There are only so many PhDs produced in the United States every year, and a relatively small fraction of those would be of the quality we would hire. And so if we really wanted to grow and grow with Microsoft, I felt we needed to do that. We were extremely fortunate in being able to hire Roger Needham, who had really been a pioneer at the University of Cambridge in the computer laboratory there, had run that organization for many years, was tremendously respected in Europe, and was a friend of mine. He had come to a point in his life where he was interested in doing new things. We started talking about creating a lab in Europe, in particular in Cambridge, And so we started that lab, I believe it was in 1997. And again, that's been growing really well for us. Our success there led us to start looking at Asia, and we felt that there was a great opportunity in China in particular because of the many students coming out of the Chinese universities and the fact that really there was no one else doing basic research in computer science there of the kind that we did. We felt that we could bring in great students and give them an environment where they could be productive and make a difference for Microsoft. And so we started that lab in, I believe it was 98, and then we've been growing since then. We've since created another research lab in the United States. We have a group in Bay Area now, and the most recent lab we started was in India, in Bangalore. And again, in each case, it's always about the opportunity that region presents to us to hire great people and to make a difference. Now, that said, one thing I've discovered is that as we have these labs in other countries and other geographies, it's also been given us other opportunities. I mean, the researchers coming from those environments have different perspectives than those that we might hire here in the U.S. That come out of U.S. universities. And so, you know, it takes us into research areas that we might not have gone into before. It looks in many cases at problems which are local to that geography. You know, so, for example, our lab in India has started up a very strong program looking at how technology can improve life in rural communities and can improve education. That's particularly important in India, and they've taken a leadership role there. And it's just an example of how, you know, the researchers in a particular geography bring their own perspectives, you know, into solving research problems.
Yeah, good. Well, so now you've collected what as an academic I'd call as the best computer science department faculty in the world. You've got a dozen or so members of the Institute National Academy of Engineering, yourself included, and incredibly distinguished folks. Roger would be a great example of that. Where do you want to go with that talent pool in the next 15 years? What's next on the horizon for Microsoft research? And let me ask a related question. How do you set the research agenda inside Microsoft Research? Are the individual, I almost said faculty members, researchers, are their research agendas just strictly curiosity driven, or do you try and steer the enterprise in some specific direction?
Well, I'll answer the second question first. There really isn't, you know, a good mechanism by which I could steer the organization. The best opportunity we have to steer the research is by the people that we hire, and what their interests are and where, you know, what their talents are, and even there we're really driven more by the quality of the people than we are by specific areas. I mean, if I have a chance to hire an incredible person, it may be in an area we were never thinking that we would do research, and then suddenly we're doing research there. So, you know, to me, you know, I don't really think about directing. What we do is we make sure that our researchers understand, you know, what's happening, you know, broadly in the community. So as they think about the research, they're certainly aware of what the Microsoft product teams are doing, what's happening in the academic world outside of Microsoft, what's happening internationally, and certainly that can have an influence on what people do. But in some sense, you know, the goal is to have great people that figure out where they're going. And I must admit, I come into work and I'm not infrequently surprised by some research project that I've never heard of before that we're working on. And to me, that's good. I mean, that's what makes my job fun. In terms of where we're going to go in the next 15 years, I mean, I just hope that we will still have 15 years from now the kind of vibrant environment that we have now. I think we've been incredibly lucky in because of frankly, because, you know, Microsoft believes in doing basic research. It believes in supporting the work that we do. We've been very lucky in being able to build a stable research environment, you know, with the same set of goals and the same mission, and not change that, you know, for 15 years. If we can continue to do that for the next 15 years, then I think the sky's the limit in terms of what we can accomplish. What technologies we'll be doing then, like I said, I get surprised every morning, so my ability to predict 15 years in advance is probably poor. But I'm sure it's just going to be exciting if we can continue to move forward the way we have.
But let me put you on the spot just a little bit. As a computer scientist, if you got to pick one or two or three really interesting problems out there, intellectual problems in the field, that you'd love to see cracked, that you think would have some really significant impact on our understanding of computer science and the field overall, what might those be?
Well, I think there's several areas I'd point to. I think we've only scratched the surface, for example, in the biomedical area, in terms of what computing could do to improve people's health. Mm-hmm. I think that
and control the cost of healthcare.
I met with the governor and the governor's staff, and the cost of healthcare is very high on their list of issues that the state confronts. Internationally, every country you go to, everyone is looking at the cost of healthcare as a major part of the concerns that they have about their ability to support their citizens in the future. So I think there's a huge opportunity to be able to bring computing technology and the underlying theory of computing into the biomedical area and have a big impact. I think another area that is extremely important is the environment. And again, I think that's an area where technology could play a very significant role. One of the research projects we've had here for the last few years, for example, has been looking at traffic analysis and traffic prediction. It's actually one of the technologies we've licensed out to a outside startup now who's going to be bringing that technology to market. And again, the opportunity is as we can collect more and more data about our cars and how they're flowing through our cities, and if we can get that data back to the cars and to the people driving them, there's an opportunity to positively impact traffic flow, to provide much better data to urban planners so as they think about how the roads work, and ultimately to think about new ways to drive the transportation system in a way that's more energy efficient and does it, respects the environment. And I think that's really important. And that's just the tip of the iceberg. I mean, we're doing research. We're working with, for example, we're partnering with the University of Washington in oceanographic studies, right. Project Neptune, really looking at what's happening on the deep sea floor, being able to stream live information to scientists so that they can understand what's happening and hopefully in the long run help to preserve that environment and improve upon it. So those are just some of the challenges. I think there are many others. I think just augmenting what people can do, how they manage their lives and supporting it. We're capable of doing much more now than we've delivered, and I think in 10 or 15 years, we could help to solve some of the real issues that people have. So I'm an optimist about technology. A lot of times people worry about what could happen. Where is technology taking us? In my experience, I think it's allowed us to do so much. It's allowed us to improve so many people's lives, and I think the next 15 years will take that even farther.
I agree. What are the flip side of that? What are the biggest challenges that Microsoft Research is going to face in the next 15 years? Let's say 5. 15 is a long time frame.
Well, let's see. I can answer that two different ways. As an organization, a research organization is always challenged to keep the quality of its work high, keep the quality of its staff high. I mean, in some sense, as I said in the very beginning of my conversations with Alan Newell, research enterprises are very fragile. It's very easy to start to lose your edge, perhaps lose your best people if you're not careful. And so I think organizationally it's important to always keep striving, to always keep moving forward, trying to improve, making sure that you're really subjecting yourself to external criticism, that you're really doing the best work you possibly can. So that's, in some sense, that's my personal, top mission. Organizationally, I think that it's always a challenge to take great research and get it into practice. I often talk about technology transfer as a full contact sport. It's not something that happens by accident as often as you would like. It can happen by accident, but mostly technology transfer is hard work. It's hard work on the researcher's part to identify the work that makes sense to transfer, to put it in a form that can be used in technology transfer. It's hard work on the receiving end, the product groups, to figure out how to take advantage of research or how research can solve problems that they have. And we actually have a team of people whose sole job it is to help do technology transfer, and it's hard work on their part too, because they really act as the glue that brings the two sides together. So again, I view that as an ongoing challenge, and it's not something you could ever slack on. You have to keep pushing and pushing.
Well, my last question then is one that was brought to me by Tyrone Willingham. He asked if you could help with a defensive strategy for Southern Cal.
Landmines would work really well. They've got a pretty good team. Obviously. But University of Washington won this last weekend, so you guys are on a roll.
Well, we'll see if it's a roll or just a fluke. But in closing, you must be enormously proud of what you've created. It's a great anniversary, 15 years of constant discovery. You've assembled this great workforce. You've been able to contribute an awful lot to the advancement of the field. And so I just want to congratulate you and Microsoft on having done a wonderful job. The great partnerships with the Academy are terrific. The technology that's moving into the hands of people is very exciting, and it's been a delight to get to chat with you.
Thank you, Mark.
My pleasure. Thank you.
In your future, I see a woman. No. I see treasure. No. I see wireless routers, self-discovering and forming ad hoc networks.
Actually, we've been doing the whole mesh networking thing for a while already.
My ball is warming up. Now the future. I see a camera. You wear the camera, and it sees everything.
Well, actually, that sounds a lot like the Sense Cam. It knows everything you're doing, and it records all the important stuff.
My prediction came true.
You see, here's the thing. We do this kind of stuff every day. We're from Microsoft Research.
What it is? They say Microsoft Research.
May I? I see a user interface. Floats in the air, and you can manipulate it with your hands.
It's called Touch Life. The interface is like using a physical object.
We've got software that sorts through your digital photographs, groups them, and then presents you with the most memorable ones.
I sense that you are a lover of adorable kitties.
Yeah, we're making IDs that use your face and a private key to certify you. What's really cool is that you don't need a secure printing process for the cards. In fact, you just need a business card reader and a public key to verify who you are.
I like this. But what about the spam in my inbox?
Oh, we're definitely looking at ways to combat spam.
And what's really amazing, the same technology that blocks spam might be used to help develop an AIDS vaccine. Turns out our software that looks at variations in spam is also looking at variations in the DNA strands of HIV.
You change the world.
Look at what we're doing in India. We're trying out text-free interfaces for non-literate people.
We're also looking at how to expand the use of PCs in educational environments by using multiple mice per computer. The Multimouth project...
Stop. Go.
Cool.